Okay, good morning. I am Professor David J. De Los Reyes. Okay, it's July 1. The time is around 1:31 a.m. Okay, my topic for this morning will be, it is now this morning. Okay, I'll change the title of my topic. I will add something on the title. So this will now be college algebra. So it handles all the other algebras, okay? So my topic for tonight will be a long form video format, and the title is College Algebra. This will now be lesson number 8. Okay, I edited the titles on my previous lessons 1 to 7, so I put College Algebra already. So this is now College Algebra. So even though you are in high school or secondary thing, something like that, all your algebras will be tackled. Okay. College Algebra, lesson number 8. For lesson number 8, we are now through with the fundamental operations, the order of operation. Okay. So let's try to give out a topic on, this will now be properties of real numbers. For this morning, we will be considering only real numbers because there are complex numbers, and that is a different discussion, okay? So for tonight, we will just limit our discussion to real numbers. What are real numbers? Real numbers, this is very interesting in electrical engineering because in electrical engineering, what they call this, we got the real part and the so-called imaginary part, and that real part is actually the real number. The imaginary part, that's another discussion. So for tonight, we will just only be discussing real number. So if we mean a real number, it has no imaginary part. Imaginary part, it will be designated by letter I, right? So it is just something like, supposing I will write here 3 plus I, no, I4, something like that. Letter I and 4. This number is not to be considered a real number because it got an imaginary part. So for tonight, the i's of 4 is actually missing, so it's only like this. So what remains will be 3, and that falls under integer. It's a positive integer, and that will be called a real number. So for tonight, the imaginary part is missing. So the number one condition for it to be real, it has no imaginary part. Because before we discuss real number, we should know what is real number. Because we will be discussing its properties, so at least we know what is a real number. Number 2, what we call this definition of a real number, it could be a positive and negative integers. Okay, for integers, it could be 0, right? It could be a positive real number and a negative real number. Okay, so there are 3 classifications for positive and negative for integers. 0 is considered there should be a positive integer and a negative integer. The number 3 definition should be it contains fractions. Fractions, the ratio 3/4 maybe something like that. Okay, or in terms of an equation, it could be an A/B. Oh, that's fraction. Oh, that is to be considered real number. It has no imaginary part still. And for the decimal values, it will be something like a 3.5, something like that. Okay, so there is a term here, decimal. So this point here refers to decimal. Also, these are the 4 sub-classifications of a real number, or definition rather. It has no imaginary part. Okay, it contains positive and negative integers, and that includes zero. Integers, I think by definition, it should be an exact number, something like that. Fraction, we know what's fraction. There should be a numerator and denominator. And for a decimal number or decimal value, it should be a number that it has a decimal thing. So that's a decimal, it has a decimal value. So that is to be considered a real number. So we are only considering these definitions for it to be a real number. So, okay, let's try to bring out actually there are 6 properties of real numbers. But since it is 6, for this morning I will only be discussing 3 properties. Actually, when I took up my college algebra, I didn't really memorize all this, what they call this, distributive, commutative, or associative, because these 3 properties actually will come out in our so-called simplification. What we are doing there is actually some part are distributive, some part are commutative, some part are associative. So for tonight, let's study the concept of what is distributive, commutative, and associative. Okay, only 3. So because the next time around for lesson number 9, I will be discussing the next 3 properties of real numbers. I could not include for tonight because, it's a 6 topic, so I will only be discussing 3 topics for tonight for the properties of real numbers. Okay, let's try to bring out number 1, the distributive property. For the distributive property, I annotate here, I place an annotation over here, you distribute. So this actually applies for multiplication operation. So if we try to bring out the distributive property, I think this applies to the multiplication process. That is, it is denoted by, I will now be presenting an expression, a small letter a times the quantity b plus c close quantity, and this should be equal to, okay? If we try to take the equivalent of this under distributive, that's why I told you, you distribute. So you just distribute, you just expand. You are given a quantity and it is multiplied by this a here. So under distributive, you distribute. You just expand, right? So the right hand side can be the product of a times b will be ab, and the product of a times c will be ac. That's it. That's the distributive property. As simple as that one, right? The other one, if we try to combine, if we try to write first b and c ahead of a, okay? So I will write here quantity b plus c close quantity multiplied by a is equal to, okay, b times a is actually ba, and c times a is actually ca. And what's the difference of these two here? There's no difference because we perform an operation multiplication. Right? We perform an operation multiplication. So under multiplication, we could interchange what is ahead. So meaning AB will be equal to BA. Right? It doesn't matter. If you put this one ahead, okay, and the next one you put it on the second part, there's no problem because the operation is multiplication. So under the so-called distributive law, you distribute. So this number 2 expansion is actually, it seems it's nonsense, right? Because you just put this one ahead instead of on the second one. But since the operation is multiplication, it does not affect the value. That's why I told you originally, A times the quantity B plus C will be AB plus AC. I will put this one ahead. Okay, I could do that under multiplication. This is multiplied by A. And if we try to expand, it will be BA plus CA. Because AB and AB is actually equal to BA. There's no problem with that, as long as the operation is multiplication. I think I cannot see the importance of this one. That's why when I took up my college algebra, I didn't really concentrate on this one. But since I am teaching algebra now, I must have to bring out the concept of what is the distributive property. Then under the distributive property, you try to distribute. Okay? You just expand what is given. That is, the product A times the quantity B plus C will be equal to AB plus AC. And the other variation, if you put this one ahead, so this will be B plus C times A. If you try to expand, it will be BA plus CA. But this AB here is actually BA. They are the same because the operation is multiplication. And A times C will be the same as C times A. Oh, that's distributive law. Right? An example of this, if A is 3, B is 4, and C equal to 5, we will follow this. 3 times the quantity 4 plus 5 is equal to, okay, under the distributive law, you just expand, you distribute. So 3 times 4, that will be 3 times 4. 3 times 5, that will be 3 times 5. And if you try to take the simplification, okay, it will be 12 plus 15, and that will be 27. I brought out this one, so on the next variation of the solution, the result should be the same. So we could compare the values if they are the same. Okay, and using the second variation, we just put this one ahead. Okay, you can interchange. Anyway, the operation is multiplication. So the quantity 4 plus 5 times 3, it's the same. 4 times 3 is 4 times 3. And 5 times 3 is actually 5 times 3. And if you try to take the simplification, 4 times 3 is 12 plus 15. And the result is 27. So under the distributive law, for variation number 1 and number 2, they're the same. Because the operation is multiplication. So just think of it that if you say distributive, it refers to the operation multiplication. I do not see the importance of this one actually. The second property, it's the so-called commutative. Okay, just change the arrangement. And if we say commutative, this falls under the operation. Okay, the first one is addition. Okay, the second one is multiplication. So there are two operations that is involved under the commutative property. You just change the arrangement. That is, in layman's language, I put it, change the arrangement. Anyway, the result that will come out will be the same. So under addition, if we are considering two terms for the meantime, that is A plus B can be written as B plus A. I just changed the arrangement on the right hand side. I put this one first and this one as second. So I changed the arrangement. So under commutative, under the operation addition, you just change the arrangement. That is A plus B should be equal to B plus A. Right? It doesn't matter. It will not change the value of the equality or the equation. Or under the operation multiplication, the product A times B, this is that. That is understood to be multiplication. You can place it that. You don't have to place it that, or you put a quantity, something like this. Right? That is understood to be multiplication. But for simplicity now, so it looks good, we'll just write the product AB. A times B. So under the commutative property, which falls under the operation multiplication, the product AB is the same as the product BA. You change the arrangement. You put B here as the first one and A as the second one. Anyway, the operation is multiplication. It does not change the value. Okay, that's the second operation. What's the importance of this one? I cannot even say what's the importance of this one. Maybe in the so-called derivation of formulas, there are some manipulations, and you will do this to bring out a certain formula. Because I have encountered this one under advanced mathematics. You do some manipulations, okay? You try to do something as long as you don't change the value of the equation. Okay, to bring out an example, if A here again is equal to 3 and B is equal to 4, using the operation addition, that is 3 plus 4 will be equal to 4 plus 3, because the result is 7, right? If you add 3 plus 4, that will be 7. And if you try to reverse how it was arranged, 3 plus 4 is just the same as 4 plus 3. So 7 is equal to 7. I don't see the importance of that one. How about the operation multiplication under the commutative property? The product 3 times 4 can be written as 4 times 3, because 3 times 4 is 12, right? And 4 times 3 is still 12. So even though we change the arrangement, we didn't change the value of the given expression. That is 12 is equal to 12. So it means if we try to follow this, 3 times 4 is equal to 4 times 3. Okay, that's commutative. The third one, or the last for tonight, because the next time around I will be discussing another 3. I think the next 3 will be, it's a higher up, what you call this concept. For this distributive and commutative, I don't see any importance of this one. It's just that we are studying the concept of algebra. That's why I brought out what's the concept for the distributive and commutative. And the last one for tonight will be the associative property. And under the associative property, I place it here in summary, change the grouping. So we are only adding. So under the associative, the operation is also addition and multiplication. Okay? Meaning, we are adding terms and there are signs of grouping. So if we change the signs of grouping, it doesn't change the value of the equation. Like A plus the quantity B plus C, close quantity, should be equal to, I could group A and B. Okay, it will not change the value of the equation. So I can write it as the quantity A plus B plus C. So these two are the same. So what did I do on the right hand side? I changed the grouping. Change. But it doesn't change the value of the equation. Because A times plus the quantity B plus C is equal to the quantity A plus B. I group A and B as another option plus C, and they are the same because the operation is addition, right? Or under multiplication, the product A times the quantity BC plus quantity equal to, if I will now try to combine A and B, I can write the product AB under one quantity, so I change the grouping, times C. So meaning to say, A times the quantity product BC close quantity should be equal to the product AB under close and open quantity. This is times C. It does not change the value, so it will still be the same. So under the so-called associative is actually under the operation addition and multiplication. you just rumble it. Anyway, the operation is multiplication for the second one. For the first one, no matter what you combine, as long as you did not change the value, it will still be the same. Right? So I will repeat it. A plus the quantity B plus C can be written as the sum of A and B under one closed quantity. So I change the grouping. This is plus C. For multiplication, the product A times the product of B C under one quantity should be equal to. I will now combine A and B. This is multiplied by C. I change the grouping. So under associative, always think that you are changing the grouping. It does not change the value of the equation or the expression. As an example for this, there are three terms here, right? So I will still use the value ABC, that is 3, 4, 5. So I will try to follow this one, 3 plus the sum. The operation is addition. So it doesn't matter if there is a quantity here. There's no problem. Because it's all plus, right? It does not affect the value. It can be written as the sum of 3 plus 4 under one quantity plus 5. If we try to simplify, that will be 7 plus 5, and that will be 12. Right? On the left-hand side, if you try to perform the operation now, 4 plus 5 is 9, plus 3 is 12. So 12 is equal to 12. Right? That's the same. You just change the grouping. Anyway, the operation is addition. It doesn't matter. So 12 is equal to 12. For the second one, the product 3 times the quantity 4 times 5 can be written as I will combine 3 and 4 now. So this is 3 and 4 under one quantity. The operation is multiplication. And still, it is to be multiplied by 5. So it doesn't change the value. Right? So 3 times 4 is 12. Right? Times 5, and that will be 60. And here, if you try to perform the left hand side 9, this is 20, right? So 3 times 20, that will be 60. Okay, so 60 is equal to 60, it is true. Right? So no matter how we group the resulting next operation, it doesn't change the value. The operation is multiplication. Oh, that's it, guys. The 3 properties of real numbers for this morning, which is distributive, and this distributive applies to the operation multiplication. This commutative, always think that the concept under commutative is you just change the arrangement. It does not change the value of the expression. Change the arrangement, it doesn't matter. For the associative, you change how you group the numbers in the given expression. It does not change the value whether addition or multiplication. Okay, that's it, guys. That's the 3 properties of real numbers for tonight. So for those of you who are taking college algebra, this is for you guys. Because under my long video format, I will be discussing concepts. And I will be giving example problems for you to analyze the concepts that is given. So maybe after this, I could give you some example problems on how to evaluate problems under distributive, commutative, and associative. But the next time around, I will be discussing the next 3 properties of real numbers. Okay, it's 3. I will not mention it for tonight because I will be discussing that in the next lesson. Okay, so if you want to subscribe to my channel is at youtube.com/@proofdavidjdelos. If you want to share it, please click share. Good morning from Los Angeles. This is Professor David J. De Los Reyes.